let's try. Let's see. Let's try a couple examples here. So let me get your take. So the first thing to realize is the if I have a system of differential equations. So let's start. Let's do it this way. Let's give an example. Sure. I'll just make one up. So when you made matrix equations before, you had a coefficient matrix, you had a variable matrix, and you had an answer matrix. So what are my answers? What would comprise my answers for this? What would be the solution? What would they look like?
Wouldn't it be real numbers?
No, definitely not. Not for this. My answers to this are what kinds of things? What are the answers to this? What's the answer to a differential equation?
Function.
Function, right? In fact, here I'm going to get two functions. And what are the functions? X of t and y of t, right? Okay, so my variable matrix will be xy. So what would x prime be? Yeah, so it would be dx dt, dy dt. So can I rewrite this in matrix equation form? Yes. Matrices, the nice thing with matrices is it's one big block that houses multiple equations. You guys remember this, right? So you can have an augmented matrix where you row reduce. Does this sound familiar at all? Yes. It should especially sound familiar if you took linear. Maybe it's been a little while if you haven't taken linear. All right. So I'm not talking about putting it into augmented matrix form, which back in the day would have been something like good old algebra happening here. Yeah, there. Let's put them all together. Augmented matrix form would be 4, 5, 7, negative 3, 2, 3. That's augmented matrix form. No, I won't. Pure matrix equation form would be a coefficient matrix, a variable matrix, and an answer matrix. So the coefficient matrix would, of course, be 4, 5, negative 3, 2. Answer matrix would be, the variable matrix would be xy. Is that a fraction due? And the answer matrix would be, get out of there, fraction. 3.
So we should find xy?
Yes. And so back in the day, you would have found inverse of this, multiplied both sides by the inverse of this, and then xy would have been solved, if an inverse exists. Okay, now, we're not getting to the point where we solve, and actually the methods of solving it are different. And they, like I said, they involve eigenvalues, eigenvectors for a specific type of problem that they study in A2. Okay, who's heard of eigenvalues and eigenvectors before? A decent number, yes. And it's probably the same people that took linear, right? Okay. Because that you do a lot of studying of eigenvalues, or a decent amount. Eigenvalues and eigenvectors in there. So what? So that's what we're talking about right now. Okay? So what would this one look like? So see how xy, right? So what dx dt, dy dt? That is what matrix? X prime. So the x prime matrix equals, what's the coefficient matrix?
3, 5, 4, 3.
And what goes here? Yeah, you could do xy, or more generally, so now I can say x prime equals a x, right? You can say it like that. Okay, so the section 8.1 is that same idea with most of the section blank ones, which is just, can you put it in the right form? Can you verify this is the answer? Those kind of things. I like it. Yes?
For that, the eigen, I remember that you deal with like lambda, and the purpose of that is finding a coefficient, right? Isn't it about finding lambda, a specific coefficient that matches with the a of x in a way?
Yeah,
So
exactly.
are we looking for the coefficients to this system of equation?
So again, section A2 would involve a specific kind of system of equations. So if you, how do I say this? If you were to try to solve this, and you've done enough of this kind of thing already, have you noticed how a lot of the answers are exponentials? Or that happens a lot, where you get e to the 5t, e to the negative 3t, whatever. You would get a second order if you did between these two, wouldn't you? You do d minus 3x, d minus 3y, right? And then you have the negative 5 and the 4x. You have to multiply by 4, one of them, and operate it, and the other one by d something. You get a second order de here if you did the methods that we did before. I like it. And it would be constant coefficients, which should lead to exponential answers. Okay, I like it. The lambda would relate to the coefficient of the power of the exponential.
To what degree the exponentials are?
Yes, the coefficient of the power, e to the lambda t.
Okay.
Yeah. So it is actually exactly related to writing the
So it's like the
auxiliary equation and solving for the m's. I like it. But the difference is, this isn't an alternate method. It's related to that, but this is, of course, a system of freaking DEs. So I have to do it this new way, but finding the lambda would be equivalent to finding those m's. I like it. I like it. So that would be section A2. That's what you would do with section A2. I like it. Blah, 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 blah. Oh, yeah, okay. I'm going to do one out of the homework here. Let's see. Oh, let me see what you guys think about this. Now, it says verify that this is a solution to that. Say again?
Oh, so that's for the x.
One is
Yeah, so remember, what is x? X, I've lost it, but it's xy. It's a matrix, exactly.
Oh.
So they just wrote this as a constant multiplier of this. And the book likes to use these parentheses for the matrices, so I wanted to write the same way you're going to see it. I'm used to writing the brackets. I like it.
So you're taking that function and you're plugging
Yeah.
it in for x and y. And then
What does this look like as a matrix equation? Write that down first. And then try to plug this into it. See if it works. So first step is do exactly what we did here. And the second step is to plug that in and see if it works. And you can figure out what that is because you know what x is. So if I were you, I'd actually go ahead and suck this in there. So you take derivatives, you can just see the answers right there. It's x prime. You know x is that. What's x prime?
Negative 5 e to the negative 5t, and then negative 10 e to the negative 5t.
So then in matrix form it has to be like this. So then you get negative 5e to the negative 5t over negative 10e to the negative 5t. What's the, yeah, over. What's the A matrix?
3 negative 4.
Yeah, just the coefficient matrix. And then x,
1
you're assuming it to be,
e to the negative 5t.
yeah. Now, one thing you can realize, well, I wanted to see if you guys would realize this, but do you see how you can just divide and e to the negative 5t away? It's a little weird. If you don't see that, it's okay. Do you guys remember how to multiply matrices?
Yeah.
Yes.
Both are
Wait, did we notice what? I didn't hear.
Oh, e negative 5t, you can divide them away. That's one reason they wrote this like this. But it's not a bad idea to put them in there so you can get the derivative correct, right, when you do x prime.
So you give your x value to your x column.
So all you're trying to do now, negative 5, negative 10, equals 3, 4, negative 7, times 1, 2. Is that true?
Yeah.
Yeah, 3 minus 8 is negative 5. 4 minus 14, negative 10. Check. Because the e's would have just come for the right anyway, so mathematically, there's a second way to look at why they just get out of the way. All right, let me stop here for a minute. So, you have to remember how matrices multiply, right, for this section. Is everybody cool with that? Do you guys remember that? I mean, they go row times column, row times column. How big is this matrix?
2 by 2.
2 and 2. This one is
1 by 2.
2 by 1. If the inner ones match, that means matrix multiplication can happen. The outer ones are how big the answer will be. It's kind of nice. Why do the inner ones have to match? Because I'm doing the row times the column. So the number of columns here is equal to the number of rows here, or else somebody's going to freak when he tries to go with somebody, there's nobody there. I like it. All right, I like it. Yeah.
Is there ever a situation where you'll have more than one column for your x equals or your x? You see what I'm saying? Because it's always going to be around the same. You're going to have one column times whatever that is.
So, with the ones we're looking at here, do you notice what I said earlier about it becomes a second degree? So here there would be 2. It would be a 2 by 2. So if you have an nth degree, you'll have an n by n matrix of coefficients. You'll have a n by 1.
Right, but that will always be one column. That's what I was asking. So that where that e to the negative 5t and 2e to the negative 5t, that would be long, but it could get real long to the nth term, but it will always just be one column per se, right?
It's a variable.
It depends on how, it actually also depends on how high the degree is on this to begin with. But yeah, all right, for the ones we're looking at now, yes.
Let's say you have like a 4th degree. I'm just curious. What would, like if you had like a 4th degree differential equation, what would change in that column right there? The e to the negative 5t, 2e to the negative 5t. It would just be 4 terms, right?
Yes.
But it would still be one column.
Yes.
Okay.
For one thing at a time, yes.
Okay.
Okay. So section A2 gets into a little bit deeper into some of the things you were just asking. Yeah.
Is section 8.2 extra credit or is it just regular home?
Sure, I can make it extra credit. That's fine. Online people got to remind me. Put it up there. I did finally get 8.1 up there. Okay. Yes.
You explain again really quick, I did the multiplication. Like, I don't understand, I got the negative 5.
So 3 times 1. So what? It's kind of neat. The answer is going to be 2 by 1. The answer is going to be 2 by 1. So to get the first row, first column, I would take the first row times the first column. 3 times 1 plus negative 4 times 2. That's how matrix multiplication works. And you just repeat that for however many rows and columns you got. So then to get that, so that would be 3 minus 8, negative 5. To get the second row, first column, I would take the second row, first column. Of course, it's kind of silly for me to keep saying first column because there's only freaking one column there. That's why there's only one column in the answer. I like it. How long can I make this and it still be valid? As long as I want to, right? I mean, I can keep adding shit on here because then it would just be 2 by n, and then the answer would be 2 by n. Okay, I like it. As long as you got this. Holy shit! Oh god. Okay. All right. Okay, so that section really isn't that bad because we're not solving things yet, which again would normally make us a little frustrated, but I think some of us maybe haven't done matrices in a while, so that's going to be enough to kind of tackle by itself. If you just came out of linear, this section should be like, okay. All right. How many of you guys are going to take linear after this? All right, so you're going to, I keep saying what I say, they're going to say the same thing. If you've already taken diff Q, then you know this already. So don't worry, it's going to kind of come back, like, finally. Right? It'll be the other way around for you. Okay, so we can do a few more out of 8.1 if you want to, or we can transition to the practice final.
Yeah.
Okay. I thought maybe since everybody just got it right now, if we all kind of chose, if you need one, you get one. If you all kind of chose something to look at to begin with, we could all kind of work on it together. Or if you just want to start at number 1, because we got today and Wednesday. Anybody else need to practice final? So 1 ABC is just, I just want you to tell me, I don't want you to solve anything on number 1. Just describe it to me in as many ways as you can. You see what I'm saying? Is it first order, second order? Is it linear separable? Is it however else you can imagine to talk about it? And then suggest some ways that they might be solved. All right, that's number one. And number two is where you actually solve it, but I tell you what to use. So this is really just a review, so you go back and you remember, well, first off, like 2A, why is it exact? 2B, why is it linear? You should really familiarize yourself with that, because you know in the final I'm not going to tell you what method to use, but for practice I figured it's not a bad idea. On number one, you kind of are getting a little practice as to what form it's in. Number three is the good old phase portrait stuff. 4 is that system of equations kind of thing. Let's see. 5 is is yummy. And then 6, I got 2 number 6s just because, and 2 number 7s just because. I think I was going to put all that together and just kind of stopped. That's all Laplace stuff. 6, 6, 7, 7, 8. Okay. And number 10 is the one from, well, number 10 is extra credit now. I don't know why I left that one on there. Number 10, I would ask you just to set it up in matrix form, right? But if you do the section 8.2, I'll have a bonus on the final.
Is it 8-1 going to be on the final?
8.1 will be on the final, yeah. So what do you can we agree on something to start with? Yeah.
I vote for number 3, phase portrait.
Okay.
Start with number 1, because you guys get today and Wednesday.
It doesn't matter to me. Who wants to do 3 phase portraits? Let me ask this again. If you had to do one, would you want to do number 3 first? Doesn't matter to me. Yes? A few of you guys? Number 1 first? I love it. I love it. Somebody voted for both. That's awesome. Let's do number 1 and then number 3. All right. And then number 2 we'll save for like dessert for next time.
Yeah, I kind of want a chance to go through number 2. Each still in order.
Yeah, number 2 obviously will be possibly take a while. You understand? Depending on the form it's in, they have multiple steps. Good old variation of parameters down there. Right? And of course you're going to have to like look it up, remember how to do it. Constant coefficient problem, that should be, bread and butter. I mean, that comes up several times, so it's hard to forget. But the variation of parameters, we haven't done that since we talked about it, so that's a good one to look at again. Undetermined coefficients should hopefully be pretty straightforward. Just have to put up with matching the coefficients. Okay, so try number 1, ABC, and then check your answers with each other. See what you got that somebody else didn't get.